Okay, this next section is on, what does it say? What is the name of the section? Molecules and elements, what is it? No. You're there.
Elements.
What is it?
So these two elements and compounds.
Models of matter.
Oh, is that what it says?
Yeah, elements.
Where? What does it say?
Element.
Elements and compounds? Okay. Molecules, for instance. Okay. Elements. What does it say about molecules then? Alright, now, where solutions would be not a substance. A substance is pure material. An element. Name an element. We've done this before. Carbon.
Hydrogen.
Gold. Hydrogen. Can we throw it at me? Come on, do it. Uranium. Very good. What is it? Titanium.
Calcium, potassium, nitrogen.
Okay, so these are elements. They have specific properties that are unique, and they are pure. Yes?
Yeah.
Okay, all right. A compound is the same way. A compound is a chemical combination of two or more elements. Yes?
So can there be like a compound with 3 elements?
Sure. And I'll go over a few. Sure, of course. What is it? Sure. It would be compound with all kinds of elements in it. You ever hear of DNA? I mean, DNA has all kinds of elements in it. Sure. Long chains of all kinds of things. You have a lot of like nylon, it's carbon, oxygen, nitrogen, hydrogen. You said tons of stuff. Look up nylon, chemical structure of nylon. That's a polymer. That's going to be difficult to write on the board. But let's go through this, okay? I'm going to give you stuff that is a little way beyond the text, but I'm going to include it on the test because I'm going over it. Simple as that. So if you don't watch the video, maybe you're not going to do well. You know, so the videos are going to be important. Right. Now, the first thing is you can have a solo element.
C6H11.
Aluminum. What is it? Say it again. Say it again.
C6H11NO.
And what?
NO, like nitrogen oxide.
N-O. That's it? That's what it says?
And it says in the whole bracket too, then there is an N in there.
Yeah. So that's, in other words, these are the individual units and it's all gone together. Like starch. Starch is this. It's glucose with a zillion glucose all bound together. Okay? All right. So we have compounds. We have elements. Well, the first thing is, just give me a second with that. And you can also have hydrogen, but you can have hydrogen diatomic. Yeah. In other words, there are certain elements. There's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And when they're in the liquid state, when they're in the gaseous state, they appear in nature diatomically, two together. So you put the two there. These are called diatomic. There's other gases, nonmetals, that are always monoatomic, and that react chemically. Krypton? Am I confusing myself? Krypton, right? Am I saying something from a Superman movie? All of a sudden I was watching a Superman movie. It's called Krypton, right?
Yeah.
Is it? Xenon, Krypton. Okay, good. I was losing my mic. So, what happens with these? Well, this is what happens. Are you ready? All right, so let's look at fluorine. That might be easiest. So you have fluorine, right? Now, fluorine has 7 electrons in its outer shell, right? Now, neon, which is right next to it, is called a noble gas. Yes? The noble gases are inert. Chemistry, when you study chemistry, and we're studying it now, but when you study the discipline of chemistry, you will study chemical reactions. And the only reason, well, not the only reason, but a major reason why chemical reactions occur is because the chemicals involved want to be just like the nearest noble gas. Because the noble gas defines stability. So if I'm a chemical, and I'm an element, which is part of a chemical, right? Compound, right? I want to be like the nearest noble gas. So what happens is with this has 7 electrons in the outer shell. So diatomically, if I go like this, they share an electron. So now each fluorine has 8 electrons, or 10 altogether, right? Because it had 9. The atomic number of fluorine is 9, which means 9 protons, 9 electrons. Neon is 10 electrons, 10 protons, 10 electrons, doesn't react. I hate the octet rule. It's for like, if you want to be brain dead. I don't teach the octet rule. You want to learn the octet rule, go do it on your own. In my mind, it simply wants to be like neon. What's neon? Neon has 10 electrons. Okay? It wants to be just like the nearest noble gas. So in other words, you simply count. Fluorine is 1 away, so it's going to need 1 electron. So now each fluorine has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. They're sharing an electron. So fluorine claims 8, this fluorine claims 8. Okay? Now, this is called covalent bonding. Covalent bonding. Covalent bonding. Shall I write that? Covalent bonding. Covalent bonding means you're sharing electrons. This is non-polar covalent. Very, very stable stuff. Non-polar covalent. Good stuff, strong bond. Understood? Then you could have sodium and chlorine. Sodium has 1 electron in its outer shell. Has 1. Look up a periodic table. Whatever you'd have to do online, because the way this book was copied, they left out the flap. They left out the periodic table. I know, it's kind of silly. And chlorine has 7. Right? What's going to happen? Are you going to get a sharing or what? No, because first of all, you only have 1 electron. Yes? It's not going to take on 7. Okay, you got the periodic table? Okay. Yeah? Okay. So you look where sodium is. Sodium is here. Right there. It has, what's wrong? It's all right. It has 1 electron. See that? It's in the first row. Fluorine, you count these 2 rows and these 6 rows. So chlorine has, what's the problem, guys? Yeah. Chlorine has 7 electrons in the outer shell. You can tell because these first 2 columns and these 6 columns are where the electrons are, where the valence electrons are. Understood? All right, now, so what happens is this. There's something called electronegativity. Electronegativity. And electronegativity says that fluorine is very electronegative, and sodium is not. Electronegativity is defined as this: an element's tendency to attract bonded electrons. So it's literally going to rip that electron off the sodium. It's going to rip it. It's going to take it. Because sodium doesn't care. Sodium only has 1 electron. What do you think it's going to take on 7? It's not going to happen. So you get this. So it has 11 protons, 11 electrons. It loses an electron. It's going to have 11 protons and 10 electrons. So it's going to have a charge of what? Thank you. I'm glad you're so excited to be here. She's yawning. An old hound dog. Yeah, there she is, okay. Working all day. Alright, so you have what? What happens? It has 11 protons and 10 electrons. What's its charge going to be? 11 plus ones, 11 protons, 10 negative ones. So it's going to have what charge? What net charge? Positive 1, right? Okay? Yeah, all right. Because you can yawn and do science at the same time. I like that. Okay, so sodium is plus 1, and then chlorine will take on an extra electron, a negative charge. So chlorine has what charge? Negative 1. Okay, one of each. One of each. Yes?
Is this a covalent bond?
Excuse me?
This is a covalent.
No, this is called an ionic bond. It involves a transfer of electrons. This involves a sharing. This involves a sharing of electrons. This involves a transfer. Now, this is called a molecule. Called a molecule. A single unit from a compound where you have covalent bonds. A single unit from a compound that has covalent bonds is called a molecule. Molecule. It's called a molecule, right? A single unit from a compound that has ionic bonds is called a So it sounds almost like I'm making this stuff up as I go. It sounds so silly, doesn't it? A formula unit. A formula unit is the single entity from a compound called a formula unit. Now, eraser, please. Now, I'll give you another one that's really cool. You have carbon, oxygen, and oxygen, right? I'm not going to go into how these bonds form, but this is what it is, okay? So you have 4 left over with oxygen, 4 left over with this oxygen, and if you count, each bond is 2 electrons. So 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Yes? So they each have 8 electrons. Yes? Right? The oxygen is just the oxygen, carbon, and oxygen, just like neon. All of them. Right? So that has now 8 electrons. Sorry, it's taking on 2. Right? Because it had 6. It's in, look at the group it's in. It has 6 electrons. This has 4.
Oxygen 8. Sorry, 8.
Right? You get it?
8. So oxygen is 8.
Yeah, they all have 8. Right now, we call this carbon dioxide.
So oxygen already has 8.
No, oxygen has 6, dude.
So
Look at what column is there. Remember the first 2 columns and the last 6 columns. That defines how many electrons there are in the valence shell, right? So oxygen is 2 columns away from the noble gas, right?
Yeah.
All the noble gases have 8 electrons in the valence shell. Except helium, that's 2. Get it? Yes? Alright, carbon dioxide. Is this a molecule? Is this a molecule or a formula unit?
It's a compound.
Sharing? It's a molecule. Clear?
So how is it a molecule?
Because it involves covalent bonding. If something is covalent bonding, it's a molecule. If something is ionic bonding, it's called a formula unit. Yes? Okay. What else does it ask for there? Does it talk about anything else? Can you look at that section quickly, please? What else do we have there? Pictures. Look at the pictures. Anything else? You have any questions? Please have questions. Otherwise, I get bored and I get cranky if I get bored.
So time's up.
What was that? Time's up? As in, we're done? We're finished?
2 minutes to
No, we have. Time's up. 8:55?
Yeah.
All right. Come in with some questions tomorrow. Understood? Okay.